Hello everyone, welcome to Explorer Hub. Let's take a look at our first question. Find the derivative of the plane curve given by the following parametric equations: x is equals to t to the power of 4 plus t and y equals to t cubed plus 1. So we have to find the first derivative of these two parametric equations. We know that dy over dx is basically the same thing as dy over dt divided by dx over dt. So the first thing we have to do is find dy over dt, which is the derivative of y, which would be 3t squared. And the second thing we have to do is find the derivative of dx over dt, which is 4t cubed plus 1. Now that we have these two equations, we can simply plug them in to this equation and we will get 3t squared divided by 4t cubed plus 1, and that's our solution to our first question. Now let's take a look at part B. So part B states, find the second derivative of the following parametric equations. We can see that these equations are the same as the equations given in part A. Therefore, we have already found out the first derivative. And now we can take a look at the second derivative. I've given the formula right here, which states that to find the second derivative of parametric equations, we take the derivative of the first derivative of our parametric equations and divide that by the derivative of x, which we found out in part A right here. So let's find out the numerator, which is the derivative of the first derivative. The first derivative is 3t squared divided by 4t cubed plus 1. This is the same thing as u over v. We can use this formula, which I've given right here, to find out the derivative, which would give me 4t cubed plus 1 multiplied by 6t minus 3t squared multiplied by v dash, which is 12t squared. Now we divide this by v squared, which would be 4t cubed plus 1 whole squared. Now we can further simplify this to get 24t to the power of 4 plus 6t minus 36t to the power of 4 divided by 4t cubed plus 1 whole squared, and this gives me minus 12t to the power of 4 plus 6t divided by 4t cubed plus 1 whole squared. Now this basically gives me the numerator of our formula for the second derivative of our parametric equations. So now we have to find out the denominator, which is basically dividing by dx by dt. And we found out that dx by dt is 4t cubed plus 1. So this is 4t cubed plus 1. And this whole thing is basically equal to minus, let me just change the pen color, minus 12t to the power of 4 plus 6t divided by 4t cubed plus 1 whole cubed, and that's our final answer. Let me just highlight this out, and that's how you find out the second derivative of parametric equations. Thank you for joining us. I hope